Welcome to another informative video brought to you by Ortruo. The last time we look at PET blowing process, a practical example was shown on how PET blowing process work using stretching rod and compressed air. In today's series, we will be looking at how stretching rod extends and retract in relation to the machine movement. Stay tuned.
Harry, there is still one area of concern. Because of course, I know that sensors are used to monitor the movement of the preform as it comes from the hopper. Likewise, sensors are also used to monitor the opening and closing of the molding block during machine rotations. And transmitters are used to check the temperature and pressure of fluid during fluid circulations, and lastly, the machine rotations is all thanks to the induction or servo motor that drives the machines, etc. So how does the linear motor works? Because you said the stretching rod move up and down as the machine rotates. Can you share some light a little bit?
Okay. The linear movement is done through electromagnetism. Let's look at the physics stuff we learn in high school. We all know that in magnetism, like poles repel each other, while unlike poles attract each other. So basically what it means is that, when we bring magnet of the same poles together, that is North Pole to North Pole, we will see that the two magnet will begins to repel each other. Likewise, South Pole and South Pole magnets. While, when we bring magnet of different poles very close to each other, that is North Pole and South Poles and vice versa, the magnet will attract each other. Now because one part is held stationary, and the other part of the linear setup is allowed to move freely, as a result, when the coils produces magnetism of the same poles, the stretching rods will move away from the magnetic coils, while when the coils produces magnet that is different from the moving stretching rod, the moving stretching rod will be attracted towards the magnetic coils, and hence the stretching rod moves upwards. Now in order to generate the changing poles, the direction of the currents will need to change at interval. Some machine designer uses electrical drives and some other special device to change the direction of the currents at intervals. Now the poles can be changed as per machine design. The most common one is when the mold is open. That is when preform is transferred in. The poles of the magnet will be different, thereby attracting the moving stretching rod towards the coils, and thus there will be room for preform's transfer to the mold. After it has successfully been transferred, the pole will change again. This will move the stretching rod downward and it will seals off the preforms before the commencement of blowing process. Of course you know it is very difficult to blow balloons at distance. The to and fro movements of the stretch is to allow the preform to be easily transferred in, to stretch the softened preform during blowing, and to finally seals off the preform heads. Let's do a quick recap. In this series, we look at how stretching rod moves, to and fro. We look at how magnetism was used to achieve the stretching rod movements. And finally, we ended off looking at the importance of current direction in relation to magnetic poles. Hope you have learned something new today. See you in the next one.